If I was going to summarize, we found that these new materials that we've been developing really fit in a broad range of applications. We can actually engineer them to work for a variety of different leachates. And I think what John brought up that I failed to mention is that just having enough polymer isn't enough. There's different polymers for different scenarios. So you'll have some polymers that work good with chlorides, others that work good with sulfates, and essentially engineering the product to work with a particular leachate, or you might say identifying which GCL product fits with your leachate is critical. And we do that by looking at the chemistry. They're not all the same. The variety of different products, the loading changes between product to product. Some have less polymer, some have more. You can imagine the higher polymer loading is going to be more expensive product. It's probably going to apply to different types of conditions, and the polymer type varies. So, and the manufacturing can be important as well. So it's important to not only test a mixture of bentonite and polymer, but to test the GCL product, because you can actually, as you're needle punching it, pull some of the polymer out. And so testing GCLs is important as opposed to just the material that goes in them. Characterizing the leachate is really important. For a conventional bentonite, we can take a leachate and run a swell index test, very quickly tell whether it's likely to work or not. Swell is 15, 18 milliliters per 2 grams. We have a good chance of it working with conventional bentonite. Lower than that, probably not going to work. That's not true with bentonite polymer materials. So if we go through a process of essentially saying a conventional bentonite's not going to work, and we need to pick a different material, immediately we need to characterize the leachate. And getting that done as soon as possible is preferred. Getting essentially the clock started early, you might say. I can't emphasize this as, I always get that in our lab. Can you do this tomorrow? Give us the answer tomorrow. Well, it's actually going to take us 6 months to get to the end. The tests do take a long time. I think John talked about that point really nicely about the dip in the data, and it all looks good. You want to terminate the test, and I get a lot of pressure in our commercial lab. Well, isn't that good enough? Can't we just turn the test off now? And in fact, if I let it go another month, I'm going to get a really different outcome. And it's not about getting the number we want, but it's getting the right number. And so getting tests to equilibrium take a while. We have criteria that we're working on in D3504 to develop some new standards for these materials. But it takes a while to run these tests. Some of those graphs, took 2-3 years to develop. Not that that's what you can do when you have PhD students. You can't do that in the real world, I realize. But 6 months is not uncommon, all right, to go from beginning to end. And so you want to get started as soon as practical so that you don't end up with a situation where your client wants to build something and we don't have the data back to be able to confirm that the product's going to work.